All right, everybody. This is the first video of weekly notes. So this is going to be the third video for week 5, but it's the first video for weekly notes. Okay, so if you haven't seen the schedule video or the assignment video, please go watch those before starting the notes. Okay, but here are the notes. There's going to be a guided note taker available online. No, you do not have to turn it in, but you can use it if you want. Okay. All right, so weekly notes. This kind of goes back to a little bit of a refresher from what we've seen in the past. Okay, so we're going to talk a little bit about ecological organization, then move forward into new stuff. So ecological organization, again, it's going about how do we organize the things we see around us. Okay, so first thing we go is organism. Okay, one individual member. So it's one member of the community, one organism. Okay. Population is going to be a group of organisms, group of members. Okay. They're all going to be the same species. So population is all of the elk here. Okay. Not just this elk, it's all of the elk. Okay. Going forward from there, community is a group of populations. Okay. So multiple different families, if you will. Okay. Populations. They're all going to be grouped together in a community. Okay. They're all the biotic members within that area. Okay. It has to be a specific area, and it all has to be living things. It can't be non-living things because non-living things are included in the ecosystem. Okay, things like water are going to be included with our moose or our elk, okay, or our shrub oak, okay, those kind of things. Then it goes forward from there into larger and larger things. Okay, landscape is multiple ecosystems, biome is multiple landscapes, biosphere is everything that is living and all the things that interact with that system, okay, including the hydrosphere, cryosphere, those kind of things. Okay, so that's the interactions between those things. Okay, now those the ecological organization, we can talk about the interactions between members within those specific areas. Okay, so going back, we're going to talk about specifically population interactions, community interactions, and then potentially allude to some ecosystem interactions. Okay, it's a little difficult to do ecosystem interactions. We'll talk about that in a little bit too. Okay, so population interactions. How do members within a population interact? Okay, one way is through reproduction. Okay, put simply, two population members make more members. Okay, that's reproduction within a population. Okay, remember the definition for a population is that they're the same species, and species is defined by two organisms that can successfully mate with each other. Okay, so they have to successfully reproduce to be considered within the same species, to be within the same population. Okay, so reproduction is just the making of more members. Okay, so two population members make more members. So when we talk about population and specifically reproduction, we're making more of something. So we're going to look at population growth curves. How do populations change over time? There's two ways we can look at it. Okay, and you see the two right here. We have the J curve, which is the exponential growth curve. Okay, that's the one you see on the left. Okay, growth rates of the population accelerates. Okay, and it doesn't have any restrictions. It doesn't look like it's going to stop. If we continue that graph out, it would continue to go up at an exponential rate. Okay, it looks like a J. That's why we call it a J curve. Okay, the exponential growth curve. The other way we can look at it is the S curve. Aptly named because the curve looks like an S. Yeah, science is kind of a mystery sometimes, I guess. Anyway, science curve. It's also the S curve is also called a logistics or a restricted growth curve. Okay, what we're talking about here is we're going to see that population can accelerate to a point of maximum growth where it's going to stop growing as much as it's going to decrease. Okay, and it's going to slow down. The growth rate is going to slow down, and it's going to create a carrying capacity for the environment. Okay, so that acceleration of that population is going to grow to this extent. It can't go much more than that because carrying capacity is the maximum amount of population that the environment can support. Okay, it can't go beyond that, or rather, it can't go much further beyond that, okay? What happens when it goes beyond it is that the population is going to die off and it's going to go down below the carrying capacity, and it's going to go basically teetering and going back and forth between that line. When we look at actual populations, that's what we see in the real world, is we're going to see it goes beyond the carrying capacity, and then they're going to die off a little bit, and they're going to grow, and they're going to die off, and they're going to just basically go float around that line, okay? So what affects the carrying capacity? Well, we have four main factors that affect carrying capacity, okay? The maximum amount of population that the environment can support. Four main factors. Here are the factors. Food availability, water supply, living space, and environmental condition. Okay, so looking at our little diagram here, what they are missing, or what is affecting their population growth, is living space. Okay, the ones on the left are super packed. They're packed in like sardines, but they're actually goldfish. Little joke. Anyway, they seem to have enough water, but they don't have enough space to live in, and it's going to kill off their population. Compared to the other group, the right side, they seem to have plenty of room. Okay, so factors that affect carrying capacity. Those are the four we're going to talk about. So when we look at it within an ecosystem setting, okay, we're going to compare two ecosystems for our example. Okay, we have a desert ecosystem and a riparian ecosystem. Remember, a riparian ecosystem is an ecosystem that is predominantly formed around water, okay, flowing water usually, like rivers or streams, okay, but it can be lakes and stuff too, okay, formed around water. So two different ecosystems. We're going to use our four factors to compare these ecosystems together, okay? So looking at the desert ecosystem, think about what the availability of food would be, okay? So I guess with that, it's going to depend on the species, okay? If we were to put, a moose in the desert, they're going to have a hard time finding food, okay? But, putting a lizard or a rattlesnake that's already accustomed to living there, they're probably going to do fine because they have adapted different traits to find food specifically for that area, okay? So it just depends on the species. It also depends on the season. If we had a drier season, okay, talking about water supply in a second, if we had a drier season, food availability may not be there. So it might affect the water supply, or it might affect the food supply in the area. So going to water supply, desert ecosystems are going to be predominantly formed around its supply of water. More water, more life. Less water, less life. Oh, less life. Less life, okay? Less water, less life, okay? So when you have more water, you're going to get more food, more things will be able to drink in that area, more things will be able to live and grow in that area, okay? So that's going to be the biggest factor affecting the carrying capacity within a desert ecosystem. Space, maybe. Environmental condition, also maybe. They're both dependent on human development, okay? We live in a desert. You can look around where we are. The more we grow, the less desert there will be because we build suburbs, we build roads, we break apart that ecosystem. We'll talk about fragmentation later on in the video. Actually, I think the last video we'll talk about that. Okay. Same thing with environmental condition. That's going to be talking about like the health of the ecosystem. So is it polluted? Is it disturbed? Is it destroyed? Those kind of things. It's going to be dependent on how developed it is by humans, okay? Is it going to be a mountain biking road? Those kind of things, okay? So it could be in a desert ecosystem. Riparian ecosystem. Food availability, there might be a factor of that, but mostly with a riparian ecosystem, it depends on the environmental conditions, okay? How polluted is it? How destroyed is it? What's living there? Because the food is going to be generated based off of the plants that grow there. And if there's no plants, because of the environmental condition, there's no food. Okay? Water supply, not going to be an issue within a riparian ecosystem. Okay? Because if it's designated as a riparian ecosystem, it's going to have water. It's going to have plenty of water. So we're not going to have to worry about water supply in a riparian ecosystem. One of the factors that's probably going to be an issue is living space. Because of the way humans have developed, we like to grow and build cities near rivers and lakes and streams. So those are the first places that get populated and turned into roads and suburbs and those kind of things. So living space is probably going to be an issue within ecosystems, but the biggest issue is going to be the environmental condition. Again, because those are the first places we usually build, they're going to be places that are going to be destroyed first. Okay, so the environmental condition within that area is going to be the most important factor on the riparian ecosystem. Okay, so they are two different areas, two different ecosystems, but we can compare them to find out their carrying capacities and see some similarities between each of the ecosystems, even though they're vastly different geographically and physically. So I'm looking at it, I'm over time right now, so I'm going to call it here. I'll pick you up in the next one. Okay, thank you. Bye bye.